All right, everybody. Welcome to April. It's time for our April.NET Users Group meeting. I'd like to welcome you. In case you don't know me, my name is Matt Ruby. I lead the user group along with Brian Olson, who's here with me. Brian, say hi so we know we can hear you.
Hi.
There he is. All right. We're joined tonight by Mike Gritz, Mike, who you'll meet in just a little bit. He's going to talk to us about the actor pattern. Before we get too much into that, though, I want to let you know that this is an interactive session. You can participate by following the instructions on the YouTube video description. You can ask your questions in the Slack channel or in the live stream chat, and we'll follow up with Mike right away to get an answer. Mike asked us to interrupt him tonight, so we're going to go ahead and do that. So, Mike, hope you enjoy that part of it. Our sponsor tonight is giving away three $50 gift cards for local restaurants to participants in our Slack workspace. Thanks to Tech Systems for doing that. Tech Systems has been a long-time supporter for us, and I'm glad that we can work with them on a continuing basis. We'll be giving these prizes out throughout the presentation, so keep an eye on the chat because you'll need to be present to win, meaning that I'm going to ask that you're there and that you're responsive. So we want this to be as interactive as possible. And again, all the details you need are in the video description. As for community announcements, we mentioned this last month, but it's worth repeating. Microsoft Build is now an online-only event happening near the end of May. There seems to be some more details trickling out of Microsoft regarding that event, so I'd watch that site for those details. There's a lot of other community groups who are doing presentations virtually and otherwise, and we've enumerated a lot of those on our Slack workspace, and we've continued to get more people participating in that. So I'd encourage you to check those out too. It's a ton of great material that's being just given away right now. So while you're stuck in your house, you can check out all that. So back to our sponsor, I wanted to thank Tech Systems for sponsoring our meeting tonight. They support our group in a lot of different ways, and we're very appreciative of that. They've been, I'm sorry. So at this point, I'd like to turn it over to Nate, who's going to say a few words about Tech Systems. Let me see if I can switch it. All right. Nate.
All right, we good to go?
I think we're good to go. Why don't you give it a shot?
Awesome. Awesome. Thanks, Matt.
Yeah.
Well, good evening to everybody here. Like Matt said, my name is Nate, Nate Mensch. I work with Tech Systems here in Omaha. And just for those of you who don't know about Tech Systems, we're an IT services company that provides talent services as well as fully outsourced solutions through our professional services arm of business. We actually have 110 offices across the U.S. here. That allows us to focus on our local markets as business partners and career resources. A thing that a lot of people don't know is that we're actually a global company. We have delivery centers in Bangalore and Hyderabad, India. We operate in Canada, the UK, China, and other countries as well. And here in Omaha alone, we've had a presence since 1995, actually. I'm currently supporting over 90 companies between Omaha and Lincoln as well. So that includes Kiewit, Werner, Nelnet, and Lincoln, and quite a few others as well. So as a company, we strive to understand the needs of our customers and then use that expertise to support their business and their goals. And then on the flip side of that, as recruiters, we actually are aligned by skill set, such as network, application development, and we even have a team that's dedicated to federal business supporting Stratcom and Bellevue, which is pretty cool. Myself and my team work specifically with developers to inform them on trends, local market analytics, and if necessary, share or connect them to opportunities that are relevant to their skills, goals, and interests. So that being said, if anyone is interested in talking to a recruiter about whether it's the current state of the job market, relevant opportunities, or honestly just a casual chat about the Tiger King or anything else that's fun, me and my team are happy to connect with you. I'll post our contact info here in the Slack channel in a bit, and then I'll do that at the end as well for you guys to reference back to. But with that being said, appreciate you guys' time tonight. Thank you to Matt and Brian again, and I will turn it back over to you guys.
Hey, Nate, thanks so much. I appreciate you and Tech Systems and everything you're doing for our community. Especially.
Yeah, thank you.
It's little bit of a stretch for us as we're going through this. Some of the things that are happening right now are a bit challenging, and I appreciate the flexibility. So,
Yeah.
with that, I will introduce our speaker for tonight, Mike. Mike, I meant to ask you this beforehand, so I'm going to have to do it live on the air. How do you pronounce your last name?
Greitz, with
Great.
a long I.
With a long I. All right, so this is Mike Greitz. He's going to be giving a presentation tonight on the actor model pattern. And yeah, so I don't really have much more to say about that. Mike's been working with me over at Kiewit, so I've been enjoying working close to Mike. He's a sharp guy, so I look forward to hearing what he has to say about the actor model. So let's try and switch to. Oh, Mike, are you sharing your screen?
Not yet. I will be.
Yeah. Can you go ahead and do that?
Yep.
Go ahead and transition there, and you're good to go.
All right, we're ready?
Yeah, we're ready. Do it.
Well, first I just want to say thanks to Nate and Tech Systems for sponsoring this, and thanks for Matt and Brian for having me come up and talk, and I'm glad that Matt finds me sharp rather than dull. My name's Mike Reitz. I'm the tech lead at Kiewit Technology Group right now. I get the honor and privilege to work with Matt and Brian on a regular basis. I've been recently joined the private sector at Kiewit about a year ago. Before that, about over 7 years of experience working in the defense industry. And wanted to thank everyone for joining today, and hope this can be a little break for everyone with all the COVID-19 fun going on right now. And as Matt said earlier, please interrupt if you have any questions as I go. I'd like this to be more of a conversation than just me talking to my computer screen. Right, and today I'm going to be talking about developing APIs using the actor model in .NET Core. Wanted to preface a little bit. I'm by no means an expert on the actor model. I just happen to find it to be a very interesting pattern and solution for concurrency, and specifically if you're trying to deal with data-intensive operations. So just a quick rundown of things I'm going to go over. Let's do a brief history on the actor model, go over some of the architectural concepts, some of the use cases, specifically talk about Akka.NET and Orleans.NET, do a little bit of a comparison between those, and then I have a coding demo to walk through for a simple calculator API that I put together using both Akka and Orleans. So brief history, the actor model is a conceptual model to deal with concurrent computation. It was originated in 1973 by Carl Hewitt and a couple others for a research project. The most popular implementation of the actor model is Erlang, followed by Akka, which was a framework that originated for Java, then Scala, and then the team at Petabridge kind of formalized it as Akka.NET to work in the .NET space. So the architectural concepts that make up the actor model. So an actor is the fundamental unit of computation. Everything is an actor as opposed to an object, like an object-oriented programming. And actors can only do a set of things. One of those is creating another actor, sending a message, and designating how to handle the next message. Actors are isolated and they do not share memory. They're stateful, and the state can only be changed by a message. And the way actors receive these messages is through a mailbox, which works as a message queue. And all that communication is through those messages. The main difference between kind of the actor model, the way it uses the messages in the mailboxes, and the actors versus object-oriented programming. Typically in object-oriented programming, you'd have an object, and then you'd have methods, and you would do method calling to be able to invoke that action, versus in the actor model, you have your actors with their mailbox for that message queue waiting to act on a message. Actors handle one message at a time. And one of the bigger differences, they work asynchronously. Actors offer fault tolerance through supervision strategies. And most of those supervision strategies are built off parent-child hierarchies, and the different frameworks kind of implement their ways of handling that fault tolerance and supervision. So kind of getting into the actor model, I feel like sometimes people just talk about it and it seems like this high-level thing that doesn't quite make sense, but when you really break it down, it's not overly complicated. One good analogy that I saw kind of describes it as if you think of an actor as like a human working in an office place. You know, you have like one dedicated job, and then say, if you remember back in the early days where you used to have a little inbox at your desk and you'd get paper that comes in there. So you can usually think of Office Space with the reports. Get one in there. That's your message. That's in a queue. You're going to take in the first in, first out, do your action on that message, and then send off a message somewhere else. And like in the actors, when you're a human at work, you typically have someone who handles that supervision strategy for you. So you're in some sort of hierarchy where you'd have a boss that you're responsible to. So it's not, you know, like drastically complicated, but when you really dig into it, as I'll show in the coding example, it's not as complex to set up as it can kind of sound when you initially start reading about it. And a couple of the top pros of using the actor model are easy to scale and the fault tolerance that it offers. So I'm hoping everyone can at least have a rough understanding of what the actor model is and kind of some analogy of like how it works. Now, usually one thing people want to see is, well, why would I choose to use the actor model versus a different programming paradigm? So if you just look at some of the practical use cases that are out there, if you start reading into it, I mean, they'll say it can be used anywhere. Any system that has the need for high throughput and low latency is a good use case. I listed off a few of the kind of areas that typically employ the actor model. It's really big in messaging apps. One example, Facebook Messenger uses the actor model. Another one would be online games like MMOs. So Blizzard Games, for a couple of the ones that they have, they use the actor model for that. Telecom systems, Cisco uses that. Also, Erlang was used for telecom equipment. In the financial industry, Goldman Sachs uses the actor model for some of their trading platforms. And there's many other examples. Then a couple years ago, I was reading about one implementation of it with the ACA project, where for the last World Cup, they had a live stats dashboard. They used the actor model to pull in stats for that.
Hey, Mike.
Yes.
Quick interruption for you. Tim Kozinski is asking, how does this fit in / compare with the service-oriented architecture? So I don't know if you're going to get into that or if this is a good time to ask that question, but that's been asked.
Sure. I didn't really have anything prepared to talk about that piece, but it's typically blends in pretty well. I mean, for the most part, the concept of it, you can create a relatively simple like microservice kind of system like with the actor model. I mean, there's nothing really against that. Probably do not have a great answer for that right now. I'd have to think on it a little more, but I will circle back to that later.
It seems to me, Mike, you could use it as the back end for a service-oriented architecture, right?
Yes. Yeah.
Yeah. So I think that's how it fit.
But that is a very good question, Tim. Thank you. So now the kind of transition into the part where I'll probably be doing the most is going over some of the implementations with Akka.net and Orleans.net. And then, not that I have anything to go over this, but there is a couple other implementations of the actor model in the .NET space. Service Fabric has actors, and then I've even seen a couple people put together systems using durable functions as actors. But this is not an exhaustive list, but the primary ones I'm going to go over in this presentation. So the first one I want to talk about is Akka.net. And I have a picture up here that kind of shows a little code snippet of the base type of actor that Akka uses, called an untyped actor. And in here you can see these the 5 methods that make up a basic actor. And the main one to talk about is this onReceive, because that's what handles the incoming message. And actors can handle different messages, but mainly only a few types of messages that they'll take. And if an actor in Akka.net receives a message of a type that it's not familiar with, it just throws an unhandled message exception. And then another piece for Akka.net with the messaging is actors send messages to references, and with the communication fabric it has in there, the reference to that actor through the actor system, which I'll talk about in a second, places that message in the mailbox for the correct actor that it belongs to. And Akka.net uses the actor system instance to spin up all these actors, and they offer a couple different APIs for building these systems out so they can be distributed across different servers. And I will have much more to go over that when I get into the code. And then the other one we're going to talk about is Orleans. So one of the primary differences is just kind of the wording of things. Like Akka.net really sticks with your traditional actor model paradigm where they use the term actors. You get into Orleans and they decided to call those grains. Grains are the heart of the system, and everything is handled by a grain, which is basically an actor. There's a few differences because grains can be stateless, they can be stateful, and then with Orleans you can also set up a grain to have persistent state with a database backend. They are asynchronous as well, and they can return either a task or a value to their caller. Every grain ensures process in a asynchronous way, which means there will never be any concurrent threads modifying a grain state. They have silos, which is basically the orchestration of the grains. And then if you pull together multiple silos, you create a cluster, which can be also spread across machines. And then the client piece handles that communication amongst the various silos and grains. And liveliness, basically the way they put together Orleans, the methodology ensures fault tolerance, and in order to ensure that, it uses a database backend to keep track of all the mappings and the communications that are happening for the items that basically go into those grains mailboxes. Right. And then looking at a bit of a comparison, let's say Orleans is a simplified toolkit for building distributed systems and allows non-experts to write efficient, scalable, and reliable distributed systems. Personally, I thought from going through it that Orleans was easier to set up and get started with in a project, but I did notice it has more overhead when you start up and you have to pull in more packages to get it to work. Akka is I would say a full-scale toolkit for building distributed systems. It offers much more granular access to the various aspects that make up the actor model. It's very powerful. They have a huge API, a lot of different unique things you can do for very specific use cases. It does take, I think, a little bit more time to get set up and get familiar with, especially if you start dealing with more complex use cases. All right. And now the part that I think will be more entertaining, going through the code. So I was going to start with the Orleans side. And to pull this in, you bring in Microsoft Orleans Core, Microsoft Orleans Server, and Microsoft Orleans Code Generation MS Build. This project's a .NET Core 3.0 Web API project. And in startup, you For an Orleans project, you don't have to add anything into startup, but in program, with that one package in here, it gives you this thing called Use Orleans, which instantiates your silo builder using a local host clustering in your program.cs file when you set up your iHost builder. That's part of the Orleans hosting package. So it makes it really easy to just get this thing up and running in a web API project where you don't have to set up some separate app. Like it can share the host builder inside your web API.
Hey, Mike, real quick.
Yep.
The resolution on the video isn't great, so it's kind of hard to see the text in the IDE there. If you could maybe increase the size of the font, or just like, I think like in the lower left-hand corner, there's the 100%. You can just increase that to like 150 or above, or you can control mouse wheel too. That'll make it bigger.
That better?
Yeah, I can read it now, so that's good.
Okay.
Thank you.
Sorry about that.
No, that's all right. Great. Appreciate you doing that.
So as I was saying, like right here with this use Orleans piece that you can bring in so it can share that host builder. And then the next part, when you set up your controller in here, you then bring in this iCluster client, which gives you access to basically grab a grain or grab an actor to perform an action. So I created a very simple calculator. It's just 4 operations. There's addition, subtraction, multiplication, and division. And I have a route for each one of those, and it goes in here and pulls a iCalculator grain, and then it it invokes a method on those, which I'll get into the grains later. So in here, I basically create this instance of my iCalculator grain, and then I'm running addition for the add, subtract for subtraction, multiply for multiplication, and divide for division. And in my grains, I created this interface for my iCalculator grain, which uses an iGrain with GUID key. And this is basically just how Orleans can map to find your actors, more or less, with the way you can set up these keys. And they have 4 different options for how you can map that piece. And then in the implementation, it's really the same concept as object, where you're just creating a method here. And for the most part, they want you to return tasks, but you could just return a float. Typically, tasks are a little better. With when you go through their examples, they tend to lean you towards returning tasks. And in here, it's just the basic math for doing a calculator. And I can just going to run it so you guys can see the startup time and everything that it ends up going through on startup, where you can see it's a little bit heavier on everything that has to get going to start your app. Because it has to instantiate your cluster, instantiate your silo, and then it starts spinning up your grains once you start making requests. So over here, I have the calculator, and let's do like 8 times 8. I'm just going to move this over so you can see. And that's a very basic example. I couldn't get a good performance testing tool to try and run a bunch of these simultaneously. I had done an example of that in the past, but when you start going at volume, you'll see how this actually scales out really nicely. And I was hoping to see if there's any questions on just like a very basic setup of Orleans before I start going and showing how Akka differs from it.
We haven't had any questions about Orleans right now. If anybody has any questions, make sure you ask them in the Slack channel. I'll make sure to stop Mike and he can follow up.
Right. And the next one is Akka, which for this you pull in Akka, and there's a couple other packages in here, but everything you need to get Akka running is in the Akka package. One of the differences in here, you don't have to make any changes to program.cs with your host builder. You just use dependency injection with a service provider to instantiate your actor system. So you add a singleton to instantiate your actor system or create your actor system. And then in here, you're going to be attaching the different properties to it to actually spin up your actors. Main part right here is this is where you're actually creating your actors with a router, so that your actor system can basically pull different actors from your system. They have a couple different routing strategies. The easiest one is just a round robin pool, and this is where you instantiate how many of these you can need. From Akka, they usually recommend under 10 for these, but depends on what your system is. That number can really change in like what you're doing with your actor system. And then for your iActor ref is where you actually set up this system here, and then you return that actor pool. And then when you go into your controller, not controller, sorry, your actor that you create, no, sorry, I wasn't learning. Your controller, this is where you actually pull in your iActor ref for that actor pool. And then when you go into, I have the same method set up as on the previous one where you have add, subtract, multiply, and divide. And in here, you go into your actor pool, you ask it a message, and you basically await the result of that. So one of the differences you'll notice between Akka and Orleans right away is in here, you're not using the same kind of methodology where in the actor model, traditionally you'd be like asking and then receiving. So it's usually ask and tell in Akka. You just kind of run your function over here. So they kind of take away, I feel like, some of the complexities that you can get out of the actor model system to make it a little more easier to just develop applications in it. Versus in Akka, you're going to walk through and I would say go through a more traditional kind of paradigm of the actor model. And if you notice in our startup, we instantiated this for our actor pool to be of this type calculator actor. So I'll show you the calculator actor real quick. And there's, as I showed, the base type is an untyped actor, but there's a couple other types. One of the easier ones to utilize, depending on what your use case is a receive actor. So the only thing this really does is you set up the different receive methods for message types and what the action it does on those. So in this case, I created the different messages, which I had an add message, I had a divide message, multiply, subtract. Obviously, for the messages, this could have been done in a much more simplified manner, but I tried to break it out so it at least showed some of the flow of it. And then everything is a response called an answer message. So in this actor, I receive an add. If this calculator actor receives an add message, it performs this action, where it adds it, and then it does sender.tell, so that means it replies to whoever asked the actor the answer message with the result of that, and it's the same flow for all the different ones, just does the operation based off what message type it's receiving. And then in the calculator controller, on each one of those methods, it goes and asks the message type. So it's asking and expecting the response type to be an answer message, and this is the message that it's passing in. In this case, it's an add message. For this route, it's a subtract message, multiply message, and a divide message. And I could take this and times by 6. Actually, I need to turn it on. That would help. Oh, hold on. There we go. Now I can spin this up. So I think with Akka, you can see it starts up a little bit faster and more or less the same response time. I've done more work with Akka on performance testing, and from the examples I had done with it, you do see a very good scale out on it when you start throwing, over 500 plus requests at it at the same time.
Hey, Mike, is this code going to be available for folks to get to?
Yes.
Do you have, maybe at the end of the presentation, you have a link to that?
Yeah, I do need to get that. Yes, I do. It's on my GitHub account, and I can email that to you as well to send out.
Okay. Yeah, we'll post that in the Slack channel here.
Okay.
All right, I'll post that.
And
Actor model demo, is that what you're called?
yes.
Okay, I found it. I'll post it in the channel there.
All right, perfect. All right, and that is pretty much the extent of the demo. I was hoping to get some questions. If anyone has any.
I haven't seen any. Brian, do you have any questions for Mike?
So between Akka and Orleans, which would you choose for like a professional project?
I think it would depend on the overall requirements, but after going through both of them, I think I'd actually lean more on Orleans because of how easy it is to set up. Unless you're getting into some more of the kind of niche pieces of Akka, like if you really need to have, they have a whole library called Akka Remoting, so you can spread out amongst multiple machines and spin up your actors and to have different actor systems on different ones of those to communicate together. I could see that, but if it's more of just trying to leverage some of the basic, scale out and fault tolerance, Orleans is much easier to get set up. And they recently, their most recent version finally supports .NET Core for Orleans.
Nice.
Okay, looks like we got a couple other questions that just came in. Says, Mike, are you currently using the actor model in one of the prod applications? If so, in what capacity?
No, but that is something I would like to get to work on.
So as a follow-up for me on that question, do you see any potential opportunities within your work environment for this pattern to be used?
I do. I think you could do some like ETL kind of work or anything where you have like data flows. I think you could set that up pretty easily. So I think on the app I have, we have a data flow piece where we pull in data. We pull in data from certain data warehouses. I think this would be a great tool to leverage with it being message based, to be able to pick up and move data to populate into a different database.
Yep. The other question was, are these generally deployed as a single exe/DLL, or do people different actors and different DLLs?
So typically you would do it kind of as one project. So even when you're using Akka, where you have the multiple instances deployed, it's that same deal. It's that same project, if that makes sense. Like you'd be deploying the same web app.
Yeah, so it lives inside of
Yes.
It's hosted inside of the web application, right?
Yes.
Yeah.
And then Orleans does have a different piece where you can actually set up your silos as separate apps living on different pieces, controlling their actors, other than always hosting them inside of a web API. Like you could have separate you could have separate silos deployed on machines, and then have your own API just like invoke those through whatever their basically client is to access them. You don't have to have it shared with the same host provider inside of a web API. And that's a newer feature that they just got deployed with .NET Core with the most recent release.
Nice. Any other questions for Mike? We'll give him a few more minutes here. I'm gonna, while we're waiting, I guess we can do. I've done one giveaway. We can do another one. So first winner was Sue Steiner. She's gotten in touch with me, so she gets the first pick of the gift cards. Second one looks like it's going to go to Jen. Jen, I suppose you guys aren't eligible since you work for Tech Systems. Nate, is that? I don't know if Nate's still on or not, but I assume we'll do another one.
Yeah, hey, I'm still here. I think it's best to re-roll that one.
Okay, yeah, let's do that again. All right, Ramachandra. I'm sure I butchered that badly, but send me a direct message and we'll get you hooked up with Nate and we'll figure out how to get these gift cards to you. So one thing to note is that Tech Systems wanted to support our local community restaurants, so they're purchasing gift cards for 3 local restaurants that we're going to give away. Nate, what were they again? I forget.
One was for Grubhub, another for Oscars, and then Rivera's, I believe, was the third. But honestly, if anybody isn't a fan of either of those 3, and they have a different local restaurant they'd like to support, I'm totally in favor for that.
Okay, great. So kind of your choice of whatever you want.
Yeah.
Super. Okay. Mike, we got a couple more questions in. And Ramachandra has gotten back to me, so we'll get you hooked up with a gift card. Congratulations. So the next question, I've lost track of it. What's the learning curve for using this?
So I think it's more of a learning curve in terms of changing the way you design systems to get used to the actor model. If you're more used to object-oriented programming, it's just kind of flipping that into being everything as an actor. And then the way you compose systems is a little bit different, but it's not a drastic change. I do think in terms of just the learning overhead, Orleans makes it a little bit simpler to get into, but Akka definitely more powerful as I think more overall application. And from what I could see, most of those larger systems actually using Akka.NET, most of the larger use case examples all use Akka.NET versus Orleans. It seems like it's a smaller footprint in that market.
Okay. Was there any other questions that I missed, Brian?
So I've got one. I know a common pattern with some actor frameworks is persistence, so that the actor can kind of manage its own persistence, and you actually don't even use a database. Have you looked at that?
So Orleans, to do persistence, actually does employ a database regardless.
Okay.
That's just part of their strategy. I think they did that to make it a little easier. In Akka, they actually have an little API for how you want to handle your persistence, which it lets you set that up how you want it to be handled.
The Orleans persistence, it's using a database. Does it kind of control the schema of that database, or do you actually?
It does.
Okay.
Yeah. Orleans takes care of that for you, and they have providers for most databases. Like you can use SQLite, Microsoft SQL, MySQL, Postgres.
Okay.
Those are included with the library, the different providers to connect to those. And then another thing on that with the supervision strategy in Akka, that's much more set up by you, like how you want to handle if you have a parent actor and child actor fail, like how you want to restore that state and handle it with persistence. Orleans tries to take a lot of that and do it for you, kind of make it auto magic.
Got a couple more people typing right now, so.
So I think we can do one more giveaway while we wait for those questions to roll in. I think we have one more. Let's see. All right, so next winner will be Greg Carden. So Greg is our next winner. Oh, we got a couple more questions that have come in. So Sunil Rathod wants to know, do you have any specific testing strategies for such solutions?
So Akka.net does come with a whole testing kit. I'm not sure with Orleans, and I did not do enough research on this to say like how I would actually go about doing different testing for it, other than knowing like the testing kit that Akka provides. But it seems it's more or less kind of the feel of like integration testing. But even with your basic, kind of the way you set up your architecture, right? Like how you have your stuff decoupled. I mean, the different aspects you can test in isolation rather easily. It's more when you start getting the integration of the system. I think it adds complexity, and that's what the Akka's testing kit is supposed to help with.
Nice. And then, so Tim has another question for you. So with Akka, could you use a key value store like Redis?
I do not know on that one. I don't see why not. I don't know if anything for Orleans or them using it to store information, but I assume you could.
Yeah, the only thing, yeah, I can't imagine a reason why that wouldn't work either.
Yeah.
One other question you missed there, Matt.
Did I? Okay, go back. You go ahead and read it.
Nabil asks, what would you say is one of the best advantages of Actor Model compared to other architectures?
I think it's just the scalability.
Scalability.
You don't have to do like, so if you think of some other web APIs that you would build out, you'd probably use like if you had Docker, you could use Kubernetes to scale those out. If you're using the actor model, some of that challenge of scaling, like if you have a cloud computing that can dynamically scale how much resources it has just for your app, like it takes care of a lot of that scalability built into the system for you.
Nice.
Sorry, typing, trying to multitask here. Is that it for questions? Good questions, by the way. Okay, well, I think that's probably it. So we've got all of our gift cards given away. 3 lucky folks got those, and many thanks again to Mike for presenting on the actor model for us tonight. As always, I learned stuff at each and every one of these meetings, so this is no exception for sure. I'm not sure what we'll do for our next month's meeting, but that will, I guess, come with the news. We'll see what happens with all the virus stuff that's going around right now. I appreciate everybody's patience, and I hope you guys are finding these meetings useful. And thanks again to Tech Systems for supporting us in doing this. So, and for the gift cards, those are fantastic. So when all of our restaurants reopen, we can go out and support those guys. So, Brian, Mike, any final words? Okay. All right. Thanks everyone for joining us, and we will see you again next month. Take care.